Okay, so the recording has started and it's December 9th, 2024. This is the Western Automation 7 a.m. technical trading class, 8 a.m. for the guys in Arizona. And today we have the pleasure of Sasha Marcroft, who will be covering a class on mechanical components used in automation systems, and specifically from Bishop Wisecarver, a line that Western Automation represents. Thank you, Sasha. It's all yours.
Thanks, guys. Morning. So again, I'm Sasha Marcroft. I'm in charge of the motion control side of our business, and this is one of the products. It's kind of a unique product, and so I thought I might cover it today. It's in lieu of using other bearings, and so I'll jump into it real quick. Let's see if this thing works now. There it goes. So the basic, we're going to do a basic overview of, who BWC is, and then, which is really just a few slides. And then the rest of the deck is getting you familiar with the basics, and then show you some pretty neat applications on how to apply the product. All right, so BWC is a U.S. company. It's actually two parts. It's in Pittsburgh, California. The other half of the company is HEPCO, which is an English company. They're two separate companies, but they work together. I'll kind of explain the differences here. So BWC, again, in Pittsburgh, it's founded by Bud Wisecarver, kind of an interesting fellow. He's kind of like what I call farmer ingenuity. He literally had an application for agriculture in the dairy side of things, and came up with this wheel, 90-degree wheel in '72, and I'm going to dive into that a little bit. So the relationship with HEPCO, BWC is the U.S. Master distributor for HEPCO. HEPCO is an English company. We'll take a quick look at those guys as well, and then BWC or HEPCO is the master distributor for BWC in Europe. So we cover everything in the U.S. They cover everything in Europe, and that's the relationship. So the key people here, in case you ever need to contact anyone. HEPCO is headquartered in England. They were founded in '69. HEPCO makes a 70-degree wheel, and BWC makes a 90-degree wheel. Again, that doesn't make much sense just this moment yet, but you'll see the difference here in a second. And so they produce all kinds of exotic ones, especially curvilinear and other big assembly type applications. So this is kind of where you'd want to apply this stuff. This is the same markets we're all covering currently. It's a nice product for dirty, wet, dusty environments. In the entertainment side of things, it's a very quiet tool. And so you'll see those on a lot of the camera booms, the big cranes. A lot of the live entertainment has, cameras on the end of a crane, and then the crane's really quiet. You don't want to have bearing noise while somebody's singing. So this is kind of the strategy for this product group. You're looking at long, dirty belt drive. It's fairly inexpensive for, you can get a 50-foot actuator. Most companies, a 50-foot actuator, something custom. With BWC, it's sort of a not a standard, if you would, but it's just part of their skill set. So part of the reason we picked this up was because they make really large rings, which you'll see in a little bit here. Super easy to align, which is another huge feature, and a simple setup, and again, very quiet. So here's the basics here's where we get into the fun stuff. So the basics of this thing is like most bearings, you get the bearing in the block, and the block moves back and forth, and it rides on bearings. In this particular case, we got a wheel that's riding on a track, and then the bearings are inside the wheel. Notice the V there. BWC does a 90. HEPCO does a 70. It does basically the same thing. When you mount the thing, when you're setting them up, you can see all the different uses on the right-hand side there. We've got clean room. We've got vacuum. High temperature is really a good one. You know, if you're in an oven type application, dusty, or, you know, laser slag, weld slag, laser ablatement, I should say. That laser ablated dust really causes problems for profile rails where this just walks right through it. General setup, you can see where my cursor's going here. You can roll the wheel on the outside of the V, on an inside of a V, on a rail. You're going to typically set up concentric bearings on one side and eccentric bearings on the other. The eccentric bearings are used for preload. And if you can see this little hub up here where my cursor is, that hub is, you can see the hole is offset, right? So when you turn this nut, you're able to get a preload on the wheel. So that's the general setup. The principle of the wheel itself, what happens is you got two separate radiuses right on a V. You got the inside radius in here, and then you got the outside radius. What that means is the inside radius is when this wheel is moving back and forth, the inside radius is moving at a slower surface speed. On the outside radius, it's moving at a faster surface speed. So, but they're part of the same wheel. So what that does is it ends up wiping the rail off as it moves back and forth, which is kind of a great feature for, you know, again, dusty applications, you know, machine chips, anything like that. Here's the principle, you know, same idea. I just kind of went through it a little bit better there. Self-wiping removes dirt from the outside of the rail. You typically want to have the rail lubed as well. When you're putting this thing into a mechanical design, some considerations you want to think about. If you look at this middle picture here, you can see how the balls are situated internally. Those little dotted X's, the dotted lines there, just means it's a preloaded bearing, right? So what that means is this middle hub is supposed to stay still, but they're balls, right? So you got a little cup here and you got a little cup up there. And if you put a lot of pressure on the side of this thing in axial load, you know, the balls want to roll out of there. So the other thing is the radial loading, right? Straight, your normal is going to be right where this red arrow is. And if you look at the actual numbers here, they start to make a lot of sense. So the radial load capacity for a size 1 is 270-ish pounds, right? The same wheel axially loaded is about, you know, 1/4 of the workload. So just note that when you're working with these guys, you know, if you load it in this direction, you know, setting up something like this, your loading's just not going to be as high. So take a look at the data before you're, you know, making any decisions. You know, the wheels get pretty large. You can get some pretty good load ratings, and this is a per wheel load. So key differentiators, great wiping action, you know, good in harsh environments. Kind of covered that a lot already. Really easy to assemble. You know, we all work with a bunch of customers that think they know how to do stuff and then know how to do stuff. This is for the guy who can't really put together a machine that well. You know, sloppy welds, you know, extrusions. It's a nice tool for misalignment. You know, it's going to be a lot freer. The loads, as you saw, the load ratings aren't as high. You know, equivalent load ratings for a pillow block or a profile rail. If the rails are not aligned, properly aligned, you know, toed in, toed out, if they're not perfectly parallel, they're not going to move. So just know that this is your tool for that guy. Profile rails don't like fine particles like powder, flour. Again, the laser ablatement stuff is super fine powder. It gets in the bearing and seizes them up. Ball screws have the same problem. Don't get yourself killed. Always, they have wiping pads. And what that does, that lubes the rail for you. They also have lube pads for the wheels. You know, you put a drop or two on there every couple of months while this thing's moving back and forth, and you're going to get a longer life. This thing does generate particles. It's self-wiping, which means it wipes itself off. So, you know, a little bit tougher in a clean room. It's possible you use clean room grease, but just know it particulates. Consider preloading. This is not a precision tool. You're going to see the catalog, and everybody thinks they're precision. They call out precision ground rails and this and that. It's not a precision tool. It's going to be great for long stuff and dirty stuff. Even though the wheels say wash down uses caustics and other nasty items. The wheels and the rails are carbon steel. Carbon is the key word. It's going to rust. You can coat the rails, but they're gonna eventually flake. They're the best horse in the glue factory, is what I like to say. All rails are gonna do the same thing. These are just gonna be a little better. All right. So not the greatest for wash down, but they can be in wash down, and they will rust. Just an FYI. All right. So some of the products, some of the choices. They've got actuators with belt, chain, and screw. I'm going to show you some manual ones as well. They've got a bunch of different product that we're just going to kind of overview real quickly here. So the key to this product is a wheel and track. If you guys are specifying it to an OEM, you're more than likely going to set up this kind of a situation here, or we can order drilled, pre-drilled. You can drill your own. There's all kinds of different rail types that we can choose. There's different hub types. There's wheels with hubs, without hubs. You can put a stud in them. So there's different. Here's the stud version. So lots of different setups. This is going to be your main go-to, for an OEM. They have these actuators, which are really awesome. This belt drive down here on the lower left is very versatile. For that long and dirty. They've got 5 different sizes, and we're quoting one right now for 100 feet. So they can get pretty long and again, pretty inexpensive for what you get on a 100-foot actuator. Here's some examples of some different tools. They have bracketry set up for gantries in case you wanted to do a gantry with a stinger. They use this same tool as an RTU for different robots. Here's that lower. This is kind of a better view on the bottom here. They do aluminum based and steel body based as well. So they've got a few different setups for these guys. This is another nice little tool. It's called Utilitrack. It comes in 3, 4, 5 wheel carriages. The unique thing about this thing, again, is that alignment I was telling you about before. This is an undriven tool, but you can put your own belt or whatever else you're doing if you're doing a big gantry. We've done a lot of manuals with these as well. You lock in one side with a V, right, radially, and then you float the other side with the C, so that your alignment isn't as critical. When you're doing a 10-foot gantry, aligning things gets a little bit tougher, especially on an extrusion. So this is a nice little tool for that kind of use. They're employing this tool right now too in a telescoping type rail that should be coming out here pretty quickly. Would be a nice little tool for extended trays. Different machines use different reasons different rails for different reasons, but telescoping is always one that we get asked about. And they have different wheel types as well. I don't know if you noticed this kind of a tan wheel here. That's a poly wheel, really super quiet, obviously low load rating, but if you need quiet, something in a medical environment, it's not a bad tool. So they have these other slick sticks, and I wouldn't recommend these guys, but it's in here, so I'm going to show it to you. These use nylon bearings on a hard anodize. It's a nice little tool, inexpensive actuator. We have a lot of choices for those, but this is the BWC versions. Not bad. Just nothing you're going to want to employ with any kind of load. The RTUs, they've got different carriages set up for different robots. So just tell us what robot you're using. We can slam the carriage on there. The holes are already ready. the cable track's already ready. It's pretty nice, simple way to do it. So that they got a low duty, medium duty, and a high duty. These pieces come in, I want to say 4 meter sections. Rack and pinion, Stover rack and pinion, by the way, the best in the land. But this is for the big heavy duty robots. Sectional, pretty convenient. Different robots that we've already set up for. So here we're going to cover the HEPCO side of the business now. So HEPCO again is the company in the UK, and BWC is the master distributor in the US. So anything in the continental North America, we are able to sell HEPCO. And we picked up, I kind of chose this line for this ring down here. It's kind of a nice little tool. You'll see more here in a sec. But they've got some unique stuff. Their wheel is a 70-degree wheel. So if you pick a HEPCO wheel and a BWC rail, they're not going to really work. But note that the inside-outside radius is the same concept, so it's self-wiping. And you can see they can do up to, pretty good loads. That's about 7 tons. They precision grades don't fall for the precision piece. It's not a precision tool, but if you want to get it around a little tighter, you can. But they have some nice tools here. This is that box aluminum beam there, to give you reference, is 3 feet, is a 1 foot tall beam. So you can set up some pretty big gantries with this. You can see the heavy duty rails with the rack in it as well. So that's a nice feature. Again, if you're designing stuff on your own, you can bolt these to a weldment and, have some pretty good luck without having to be too high precision. Here's the radials that I was talking about. These are really nice tools. If you've ever done a HEPCO, not a HEPCO, a CAMCO type application, where you're limited to a number of indexes, you're doing a big ring or something. We've done stuff from 100 millimeters in diameter all the way up to 28 feet. So this gives you a lot of flexibility. You can have a carriage type, or you can have, where you're spinning the ring. So this is kind of a nice tool. They've got inside rack, outside rack, single-sided rail, dual-sided rail. So I'm going to show you some other stuff here. You can see the lube pad over here. It's a pretty neat product line. These go into assembly cells, where people are manually passing these back and forth and doing assembly, or they're belt driven, where each carriage is attached to a belt and is driven below by a big pinion. There's a good example there. And then there's a different version with an auger. And as the auger spins, it feeds the next carriage into assembly, right? And then they're all connected via belt. So it's a nice little tool. You can shoot a pin in, for precision at, once it arrives at the correct spot. DTS is this belt style here. The DTS2 is the auger. It's a nice tool, and I'll show you some giant rings. They have a collaboration with Beckhoff. Beckhoff does the servo ring, right? So each one of these carriages is independently driven. It's an independently servo. So this is a forcer. This is a forcer. They can move along the ring independently and kept track of. It's a pretty nice unit, super high speed. And again, this is called the GFX, and it's a collaboration with Beckhoff. So they have some pretty nice tools. They do have actuators, aluminum-based actuators, both belt and screw, that are available. They're really nice. They're just a little bit high priced, but they do have some big box. I did one at they make sheetrock, and the profile here was 200 by 200, so it's just a giant actuator, right? Times however many meters long it was, but so they do some heavy duty. I think that the inside bearing was a size 30 profile rail, so to give you a feel for load capacity and everything. So they do have some nice product. And so this is kind of the end of the summary of what everything is here. This is a BWC evolution page. You can tell there's a lot of different products that you can employ. Again, all based on this V technology. They do have a couple of profile rail and round rail stages. I don't know if they're shown in this evolution down in here, that are pretty good. But for the most part, you're going to be selecting this product because of the rings or, the V track. You're thinking long and dirty again, high temperature, low, you're in an oven, you're moving stuff back and forth. Very smooth and low noise would be more of a, entertainment side of things. Big rotaries, big cutting equipment. Here's some applications. I'm going to run through some pictures here because pictures tell a bigger story, right? So Haas uses these for their doors, right? So chips are flying everywhere. Pretty much the most dirty environment you can think of, but they've got good load rating. They're quiet and they shed their own chips, right? So perfect for this kind of an application. Here's some RTUs. One of these, this one was one we've done here in LA. You can see a bunch of the UR stuff, the basic guys. Here's a big boy up here, rack and pinion. Here's a couple of long ones just for giggles. Oh, here's that unit I was talking about, the sheetrock guys. But that's like 200 by 200, so it's a big 8 by 8, profile. I think it was 4 or 5 meters long, pretty big, dirty as can be in there. This was for a alignment tool down here on the left. This is one of yours in Arizona there, Rico. Moving a bunch of product around. You can see the Z-axis here is another look at it. So it looks pretty good in the machine. Again, cardboard dust, not a friend of a profile rail. Here's some tooling applications for the big ring. It's a big helicopter blade, easy to manipulate and rotate around manually. Here's an assembly cell situation that we looked at a few minutes ago. This is the DTS belt driven, so pretty long. Here's a much bigger one, right? So you can, again, scale wise, get a feel for how the product is used in different applications. There's another big assembly. Here's how to use the track there. There's a PR series and an HDR series. HDRT is the big heavy duty guys, but it comes with rack and pinion, right, built into the rail. So now you've got some unique uses. Here's a big curve, right? It's going to make this turn. Pretty neat. We've got some different applications using this style rail. Here's a gantry application where they're doing some meat slicing. The big gantries for MRI and other type applications. We've done some weird applications with this. Partial arc is kind of neat for measuring. You can get it in segments from 90, 180, 270, and I think some exotic ones as well. And you can see how it's used here. This is doing a radial scan. Here's one for tube cutting, great in a welding application. Doesn't care. You can see this rail, it's got a kind of a hue to it. It's chrome plated for outdoors. So again, you can use them in harsh environments. It will flake and rust eventually, but I mean, who cares, right? It's in this kind of environment. Here's a big ring. Outside rack, big giant actuator, right? These wheels are 100 millimeters in diameter, so they're just this huge. That's a huge ring, right? And it's a single race on the inside. So that's kind of a good example of spinning the ring. Here's another one. This one's inside driven, right? So the rack's on the inside. Again, these are pretty good size wheels. And then down here on the bottom, another RTU, right? It's going to be moving a big unit back and forth linearly.
Gotcha. What's the RPM limit on those rotational ID and OD driven rings?
You're not handcuffed really. It's there, you know, until it gets out of control. So yeah, the beauty of it is you stick a servo down on the bottom, and then you're able to spin as fast as you want.
Because it seems to me that that's an interesting alternative for a slewing drive, and slewing
It is, yeah.
drives are very limited. They're limited to 3 RPM.
Right, right, due to the worm. Yeah, so the rack offers a lot of benefits there too. Most people don't realize that a rack and pinion is the fastest tool to use for, if you need to come up to speed for acceleration. It exceeds a linear servo, right? Everybody thinks, oh, linear servo is super fast. The fastest thing to come up to speed, acceleration wise, is going to be a rack and pinion. It may not have the same top speed, but to accelerate up to speed, you have a lot of mechanical advantages to employ. You can put a gearbox, like you can notice there's a big right angle gear motor here. So your inertial mismatches get into line, and based on the diameter of your pinion determines how fast you can get up to speed, right? So um, lots of mechanical advantage here. And then again, a lot of rotary turntables, you got the mechanism in the middle of the table, right? So you have all the torque is generated from the middle. When you have a ring, you're doing a tangential drive for the most part. This is an inside one. This would be better of a tangential here. But the point is you have this is a giant gear ratio when you think about it, right? We got to call it a 2 and we got a 10 out here, right? So 5-to-1, huge gearbox. Uh, Internal. Here's a belt-driven version, right? So we don't need as much torque, but we might need to get up to speed or have it quieter. This is another tool you can employ, and that's pretty much it for this presentation. The main goal was just kind of give you some ideas on how to employ the product. These we covered some of the industries earlier, heavily into automotive. Food and packaging is a big one for us. Aerospace tooling all over the place. Um, so yeah, really nice. We do some medical and semi, where they're doing drawer slides. Nothing precision again, but again, simple to employ. It's pretty clean, and as long as you keep it lubed, it'll last forever, right? And then here's some television stuff for sure. But anyway, I just wondered if anybody had any questions relative to the product or usage.
Well, on dial plate applications for pharmaceutical powder pill filling, I'm thinking M&O Perry and Corona. Is this a product that is accurate enough for that?
Yeah, I mean, there's a lot of ways to employ the thing. If you're doing, something like this type of assembly where you got pallets moving around, you can shoot a pin into position once it arrives. All right, let's say this is our assembly area right here for one part of the assembly. When it moves, you can pop a pin in there if you need to, like a locating pin, to seat the thing, where you need it within a few, microns, right? Um, as it moves back and forth, it's probably not that repeatable, right? Because you get this massive ring on a belt. So yeah, you definitely want to employ that with a big ring. You can do the similar idea, or employ some kind of a feedback device, right? So that you know whether you're in position or not.
With that big ring there, what would be the disadvantage to a slewing drive? Is it not handle as much force? I would imagine the overturning load is not going to be that great.
Well, yeah. So big moment loads you're gonna have a little bit higher, a little bit. Um, well, maybe just answer it this way: slew is going to handle a lot more load.
Right.
How you manage load with this is you just add more wheels, but after a while, adding wheels doesn't really get you any benefits, right? Because it's not like a profile rail, for instance, when you take the block, 80% of the balls are in contact. There's some balls that are not in contact. So when you have a giant ring like this, you add more wheels. Not all the wheels are in perfect contact. The more wheels you get, the worse it gets. So then you have to derate the thing a little bit. So, but you remind me of a question I need or something I should bring up. When you're setting up a wheel set like this, yeah, both of them have the same idea. They got both four wheels. What you want to do is set up two concentric wheels, right? And that ends up being your datum. So you're going to push the ring into the two datums, right? And then these other two wheels over here are going to be eccentric wheels, right? So this is your preload for preloading the ring. So you always want to have at least two concentric wheels as a datum setup. And then, let's say we're using 5 wheels, then we would spread out these other 3 eccentric wheels for preload. So to answer your question in a hugely long fashion, there's going to be less load rating with these guys. You can increase the load rating by adding wheels, but it doesn't necessarily, it's never going to, be the equivalent of a slew ring's moment loading capacity.
And BWC has some sizing software that would help with that exercise?
I would jump in with you, and they also have a couple of engineers that are experts at HEPCO. So yeah, between the two of us, 3 of us or 4 of us, we would get you settled in on loading, moment loading, any kind of setup, design considerations, all that fun stuff.
Okay, because this seems to me to be a nice complement, albeit noted on the lower load rating, to the slewing product that we have from Cone, because we do run into applications that are 4, 5, 6, 7 RPM, and the slewing ring doesn't perform well in those higher RPM ratings.
Right, and the slew ring kind of stops at around a meter, I think, meter diameter or less.
Yes, you're correct.
And this thing, I mean, we spec the thing for Disney up to 28 feet in diameter. So they'll listen to anything and do custom. So, I think I did one with Todd at Lockheed. We did a 10-foot partial arc ring, right? So, I mean, had it been a full circle, it'd have been 10 feet in diameter. But I want to say it was a little over 180. So that was kind of a special one. Yeah, so I've got one in NoCal right now where they're scanning the end of a pipe, and that's another partial arc. They're 3 or 4 feet in diameter. I can't remember what the number is, but right in that range, scanning the end of a pipe. So pretty cool.
Do we deal with the remnants of Vernon Tool, which is now Lincoln Electric up in the Sparks Reno area? That's a company that does welding of giant pipes for the oil and water industry.
Yeah, Lincoln Electric uses the one that was in San Diego, uses
That's right.
a bunch of BWC on their Z axis. Pretty heavy duty. It was a pretty neat tool. Yeah, so this would be great for Lincoln Electric, and I know they already employ some of it, but yeah, Mason was just starting to make some headway in there.
Okay, yeah, that seems to me to be a good application for that. That company Vernon Tool was originally in Vernon way back when, and then went to San Diego, and then Lincoln bought them, so now they're up in Sparks Reno.
Huh.
It would seem like the rebar bending people, like that outfit out in Las Vegas, Rebar Engineering, would be a good potential for this.
Maybe, yeah. I know a lot of the bending tool guys, the pipe benders and everybody, they have some heavy duty tooling, right? I've seen, gearboxes more used in heavy duty gearboxes used in that equipment more than I have rollers, but it's not to say they can't, right? I haven't run into it yet. It's good
Yeah,
suggestion.
rebar's not exactly a precision application.
No, exactly. That's what I was thinking about it. It's a good idea.
Interesting. All righty. Well, thank you. Are there any other questions? Well, Sash, you get the prize for the most concise class we've ever done.
Is that right?
Yeah. We'll let everybody go early to get an extra muffin and coffee.
Yeah. Get everybody a chance to have some coffee, exactly, and get ready for their Monday.
All right, gentlemen. Well, thanks, Sash. Appreciate your time. And it's 7:41, so 20 minutes before we have to go to work. Sorry for you guys in Arizona. And we will see you next week. I'll make the announcement on the subject sometime this week. Have a great week.
All right, guys. Enjoy the week.
Thanks, Pierce.
Take care.
Thanks, guys.